Hello.
Good afternoon, sir.
Good afternoon.
Good afternoon to all of you. Welcome back to the sir.
Okay. Can we start around 3:15?
Sure, sir.
Huh?
Sure, sir. Sure, sir.
Because some people will disturb me before that. That is why I was doing some meeting.
Okay, sir. No problem, sir.
3:10 something or 3:15 will start, na?
Okay, it's fine, sir.
Okay, okay. Huh? Yeah. Chart.
हाँ राजेन, राजेन राजेन
हाँ मैडम। हेलो हेलो।
राजेन
हाँ मैडम।
हाँ 3:15 बजे से हो गया लेक्चर।
तो ये
पटेल जी
चालू
को
तो हो
देना
रहा
था
है
ना
चित्रा।
लेक्चर। नहीं
हाँ
नहीं, ये चालू तो हो गया है। क्या हुआ, पटेल जी आ भी गए थे
हाँ
जिनको देना है ना
हाँ।
IIRS वाले। वो आ भी गए थे। उन्होंने बोला मुझे कोई अर्जेंट मीटिंग है तो मैं 3:15 से लेक्चर लूंगा।
अच्छा अच्छा, ठीक ठीक।
ऐसा हो गया। हाँ वही मैंने कहा तेरे को बता दूं, दिख रहा था ना तेरा वो ऑन था कैमरा, तो मेरे को समझ में आ रहा था कि
Madam, can you please unmute yourself?
हेलो सौरभ,
Yes, ma'am.
डॉक्टर सौरभ।
Yes, ma'am. बोलिए।
हाँ थोड़ा सा बेटा एक प्रॉब्लम है आपके लेक्चर टाइम पे ना, मेरे कुछ स्लाइड्स मिस हो गई हैं 8-10। आप लेक्चर नोट्स देंगे ना इसके?
Yes, ma'am. I will share.
हाँ क्योंकि कल भी ऐसा ही हुआ था, शिव रामाकृष्णन का पहला लेक्चर था, तो बहुत कुछ उसमें से मिस हो रहा था क्योंकि कभी आवाज नहीं आ रही थी, कभी स्लाइड नहीं दिख रही थी। तो इसके
Ma'am, we
नोट्स तो
will
मिलेंगे ना आप
मतलब
लोगों को पूरी
जी
क्लास?
जी जी जी
अच्छा हाँ, वही मैंने कहा पूछ लूं आप लोगों से।
जी
अभी तो 3:15 से लेक्चर है ना?
जी मैम, सर कह रहे हैं उसे 5-10 मिनट्स में स्टार्ट कर दो। उनका
ठीक है
मैसेज
ठीक है।
चैट बॉक्स में।
हाँ हाँ हेलो, हाँ बोलिए।
Hello?
Yes, sir. Sir, are you ready, sir?
Can you see my slides?
Yes, sir. We are able to see.
Yes, slides is on screen. You can able to see.
Yes, sir.
Yeah. Rest is okay. You can see me also.
Yes, sir. Slides are visible, sir.
Video is not received.
Video is not visible, sir.
Just 1 minute because I'll see. But it is not going out of the slide. Okay, let me see. Charge. Okay.
Okay.
Hello.
Hello, sir. Are you ready, sir?
Yeah, I'm ready. Now you can see me.
Yes, yes, sir.
Okay.
So, good afternoon to all of you. We welcome Dr. N.R. Patel, sir, from IIRS. Thank you, sir, for accepting our invitation for taking this lecture. And sir is having an extensive experience of remote sensing, especially in agriculture crops. And we will be highly thankful for this lecture, sir. So I request sir to please start the session.
Thank you, Nema, for giving opportunity once again to interact with the learned people. So, okay, I'll start with the remote sensing. Most of you must be knowing about remote sensing. How it works? It is like a mimics what our eyes can do. So it is simply acquiring information about any object on the earth from a distance or without physical contact with it. That means what our functioning, what our eyes can do. Similarly, eyes in the sky in the form of satellite can do for the monitoring Earth surface. But here our objective is not to address all issue of Earth surface, because remote sensing or satellite remote sensing has got tremendous role in various kind of application across length and breadth of globe. But here we'll only target today crop inventory. That means discrimination of different crop types and possible acreage estimation with the different kind of satellite data and methodologies. So Indian agriculture, I need not to explain you to in detail because all of you are agriculturists, but our economy is largely dependent on agriculture because agriculture is the backbone of our economy, and most of the socio-economic and rural livelihood that of the Indian population depends on agriculture. There is a tremendous improvement with respect to the liberalization and globalization in agriculture as well. So 75% of people who are living in rural area, they require to have correct info about agriculture because their livelihood depends on agriculture. Mainly those who are living in dryland areas, because those who are having irrigation management, if information available to them is little later, it will not harm much to those farmers who has got good infrastructure in farm machinery as well as irrigation facility. But those who are doing rain-fed agriculture, for them accurate information about crop type well in advance and timely, that really help them to overcome many issues or calamities which affect their crops. So they need to have a correct information about their field parcel, their farm areas, what is the different kind of infestation or different kind of effect of the weather, adverse effect of weather is there, or it is there is some pest of disease attack is there, or is there any sowing suitability because of if pre-monsoon rain is there or monsoon rain is there. So all those kind of decision, farm level decision, farmer can take only if they have correct information for their own farm. So for that, we need to have a good satellite-based remote sensing that can help to map and monitor agriculture over large area. So all we know how agriculture is important, because earlier it was a different story that we were not self-sufficient with respect to the food grain production, but today we are almost self-sufficient. Even we are surplus exporting some spices and other kind of commodities. But if with respect to the food grain, already current year it is already almost touching to the 300 million tons. Similarly, horticulture production also more than 300 million tons are there. But recently, with the more proactive role of this government, we find to certain extent pulses production has also dramatically increased. And also government has more and more focus on the digital agriculture, innovation, and the satellite-based information to be used by the various government department as well as researcher, and transferring this information to student for well-being of the farmer. So many food processing industries, cold storage industries, their location, all these new advances, what is happening in agriculture, that is mainly because of that major push given by the dispensation at the center. So here, nowadays, concept of farming. If I have to speak on agriculture, then concept of farming just changed bit large. Like that, earlier we have traditional farming system like rice, wheat, or only crops are there. Now we talk about agriculture, horticulture, dairy farming, fisheries, and poultry all together in a one hectare of field. That is called integrated farming system. Now, for those kind of farming system, we need to have a more integrated remote sensing GIS based solution to get better return from the farm. Whether we are providing well in advance for information about the agriculture, or we can provide information about the cold storage facility or food processing industries, horticulture, crop production, all those at a time, or some agromet advisory service that can help farmer to alleviate certain adverse effect of weather. So all those directly can be possible today with the satellite remote sensing. So why India, this remote sensing is challenging? Because those who are already working in remote sensing, they must be have experience. It is not that much easy to classify different kind of crops in India, because India is a monsoon Asian region, subtropical to tropical climate. But our land mass is very huge, almost 329 million hectare. Out of this, 70 million hectare is under agriculture. Now, apart from that, that is even much more than US and any countries. Apart from that, we have wide range of climate design, from arid to almost per humid, arid, semi-arid, humid, sub-humid. So many climate designs are there. We have soil types from loamy sand to red laterite, clay, all kind of soils are there. Physiography also, we have terrace, we have floodplain, we have Piedmont plain, we have alluvial plain, we have rock outcrop, peninsular India. So many variation with respect to physiographical setting also. And then also additionally, over all this climate, soil, physiography, there is also large degree of variability with respect to the cropping system also. In Gujarat, you will find groundnut based system, and somewhere you will find rice wheat system in Indo-Gangetic plain. Somewhere you will find even nowadays horticulture based system, rubber tree and tree based system is there. So there is lot more variation with respect to the cropping system also. So what I want to suggest here, that why we face challenge while using remote sensing data, because there's a large degree of variability with respect to soil, rainfall, this physiography, and even different kind of cropping system. So it is quite difficult to choose kind of satellite data to be used for particular crop, because in a one particular season, like Madhya Pradesh, where you people are there, or in Gujarat, or in Maharashtra, these are the region, multi-crop region, where you will find at a time 6 to 7 crops are going in a 1 hectare land. Sometimes, in Nasik and Maharashtra, Nasik or Nipat, Tehsil, all this, you will find, in 1 hectare field, all fodder crops, cash crop, even grapes, fruit crops, even cereal crops, all kind of crops you will find in a 1 hectare field. So it is a large degree of diversity with respect to the crop grown in a particular field. So this large degree diversity and heterogeneity impose limitation on use of satellite data. And also we have subtropical climate, so majority of our like kharif crops, rice, pearl millet, sorghum, bajra, and then other sugarcane also, cotton. These are the crops which are practiced in the kharif season. So for this kind of crop, if you want to map, we need a kind of data which can be available clearly. That means sometimes, whatever data today we have, some data is there like optical data, which are not suitable for the crop discrimination during the kharif season. But with the microwave data, we can solve this problem. So I want to say that because of this monsoon type of climate, we are limited not only because of large degree of heterogeneity, but also to certain extent because of climatic setting. That is why we have to be very much cautious about use of satellite data, right time, and right for the particular crop season. Before going into detail, for you, I want to say that there are some emerging geospatial technology apart from satellite remote sensing also, like GIS, global navigation system, then Internet of Things, then also in situ develop measurement techniques, and some data science or artificial intelligence technique. So here, if we have some kind of source of data like Earth observation doesn't mean that only satellite. It is a aerial image, satellite image, or ground measurement, all together, or certain even GIS based maps, all together provides Earth observation system, Earth observation for the monitoring agriculture. Earth observation has got different resolution, whether it's the spectral resolution, partial resolution, and temporal resolution. Temporal means frequency, how frequently a particular image from the satellite is available at the ground. Like, okay, coarse resolution data, Modi's or some other, which are having almost daily image. But nowadays we are having one kind of satellite from India, that is ResourceSat, advanced use, which is having 5-day image. 5-day you can get satellite image. Then we have LIS 3, which has got 23.5 days or 23 days image. So these all, what we see, that resolution is very much important, though it has got temporal resolution as well as partial resolution. At the same time, this Earth observation, whether it is satellite, aerial image, UAV, or any other spaceborne data, it cannot be used perfectly if you do not integrate with the GIS. So nowadays, because earlier only 5-10 years back, with the satellite remote sensing, you can derive many things. But nowadays, with the availability of non-partial data set or other kind of in situ measurement, we integrate satellite data with other non-partial data and other things already existing information, like for crop mapping, existing revenue department or village level crop statistic data or block level crop statistic data is available. So that can help you to discriminate better way the different kind of crops. Then, so GIS is a technique that enables you to manipulate, analyze, store, and visualize data. Visualize geospatial or reference data. So integration of ground truth, partial database, ground sensor, and crowdsourced data, what can be possible with the geographic information system. Similarly, there are global navigation system. Recently, 4-5 years back, we have launched IRNSS, our NAVIC. That is a navigation system for India. So that has got 4 satellite IRNSS and it becomes NAVIC. So that has got capability to provide you a location information, mobile mapping. You can also do particularly this kind of GNS along with GIS and remote sensing. It helps you to do precision agriculture, means correctly monitoring crop and soil condition within a field for certain farm-based decision. So within field, what is the variation in soil, what is the variation in crop type, crop condition, whether pest or disease effect is there or not, and if it is there, how much, all you can analyze in precision agriculture if you integrate all these 3 technology together with variable technology. So it alone, okay, you can prepare map, but suppose you want to make use of these all geospatial and earth observation data to offer farm-based decision making, then we need to have these all 3 tools, GIS, earth observation, and GNS, along with the certain data science or other technology to be integrated and provide solution for the farmer oriented problems. So application mainly of this technology is informed decision making for the farmers or for the policy planner, both. Because if you are using kind of data sets, it can be useful for the crop insurance map, that you can generate crop insurance claim, compensation of crop insurance claim. You can generate crop insurance index directly from remote sensing and all those things. Then it is useful for the farmer. But same thing, if you are generating crop statistical data, crop acreage at the district level, then it will be useful for the planner. So it depends on the kind of output you are generating and how it is useful to the farmer, policy maker, or the researcher like you. Mostly, okay, I believe that you all are either assistant professor or some researcher. So all those can be useful to researcher or planner, or you can say student or farmers. So in India, It is a most vibrant satellite space technology. Our India segment, that is space segment, is a very much vibrant. We have been launching different kind of satellite, beginning with the Aryabhata 2. Then we had even more, some force resolution, the IRS 1A, 1B. Then we had IRS 1C, 1D. Then we have ResourceSat. Then latest we have got also nowadays high resolution microwave like Reset 1. Then we have got also OCM, ocean color monitoring. We have got also weather related satellite like Inset 3D, which provides imager, sounder, as well as occultation technique. We have got also specifically CAAST-JNKVV, which is very much useful for the wind direction, wind speed, and also for the to satellite soil moisture. We have got Saral Altica for different altimetry. So you can get waveform in the ocean or in the water, also river, also you can generate waveform. Cartosat, we have got 1, 2, 2A, all those satellites which are very much useful for deriving digital elevation database. We have got now very high resolution Cartosat DEM available for the user for various kind of watershed parameterization or different kind of modeling. Even you can use that DEM for the slope generation, like in field farmer. If you want to adopt precision agriculture or any farming, we require slope information, because suppose you want to irrigate, unless you don't know the slope within the field, your delivery of irrigation, that will be waste. Much more water is wasted. So if you want to efficiently apply water in your field, you need to use slope. So use of slope along with the soil fertility and soil database, you can better plan the irrigation delivery within the field as a measure for the precision agriculture, like ResourceSat and Reset 1. So in Indian space technology, we have moved from the 1 kilometer satellite picture to today we have 1 meter. Now satellite picture, earlier it was available only 1 kilometer resolution. So where you cannot see your house, only you can see general agriculture, forest, like that. Now today you can even able to see your car parked in front of your house in the satellite image. So 1 meter resolution, we have moved from 1 kilometer to almost 1 meter resolution, and all those, it is not only the partial resolution. Satellites are now available with the more frequent image, like Sentinel, Sentinel 1, Sentinel 2. These are the some satellite which has offered 7 weekly satellite image you can generate with the 10 meter resolution, 10 meter interval image you can generate for every week. Similarly, we have list 4 also. List 4 within our ResourceSat 2 and 2A, that is a 6 meter resolution. Every week you can get 6 meter resolution if you composite. So potential, if you see, potential is many for agriculture. So agriculture, land monitoring, crop area estimation, drought monitoring, horticulture crop assessment, cropping system analysis, command area, irrigation command area management means irrigation scheduling, irrigation water requirement, soil mapping, pest and disease and early warning, inland fishery mapping. All are the different facets of remote sensing or space application in agriculture sector. But most prominent application of remote sensing in agriculture is crop area mapping and acreage estimation. For that, satellite which are operate in the optical as well as radar domain, radar imagery. Optical means satellite which measure amount of energy which is being reflected from the different crop types, and it is recorded by the sensor. That is called optical satellite data. But radar means radar satellite is platform which has got its own signal of the illumination. It gives it sends signal from the satellite to the object and backscatter signal again measured by the sensor. So that is why, and this particular radar imagery or microwave radar imagery, which is highly capable of penetrating irrespective of weather. It can penetrate through the cloud. That is why you can acquire very good satellite image or information about the different crop types even during the rainy season. That is why this reset 1 radar set and other kind of NV set, other kind of satellite data which are operating in microwave domain are being used for monitoring crops which are cultivated in the Kharif season. Because agriculture, it is not like that. Agriculture only happen during the Rabi season. So for Kharif crops, mainly microwave data are being used for continuous monitoring as well as generating crop acreage estimation, particularly like rice, maize, and other crops. But this satellite data, if we combine them with the meteorological information, because all of us know, and right now, okay, also it is a month of August to start. Many places there is a good amount of rainfall received, but in the June 10 by not June 10, even by June end also, and first up to July 10, there was okay scanty rainfall almost across the India, most of the state. But last 10 to 15 days, God of rain has satisfied almost our all farmers and other people also. So now it is almost, you can say, normal. Little bit deficit is there sporadically in different state, but now it is normal. So what I want to say that because this meteorological information, rainfall data and temperature, that is very much important to decide when crop to grow, when it will okay reach to the peak stage, when it get harvested, and what, because of the temperature and rainfall and humidity, it also govern the pest and disease. Pest and disease development is also related to humidity and temperature only. So what pest it will attract, that also it depends on the meteorological information. So satellite data only give you a different kind of crop type mapping, or you can say crop cover condition. But meteorological information like temperature, rainfall, solar radiation, which are very much critical for the photosynthesis process or process which determine the biomass and yield. So final economic produce in agriculture largely determined by the meteorological parameter. That is why we need to integrate satellite based information along with meteorological information so we can generate better information well in advance to monitor agriculture and finally help farmer to make certain farm based decision or farming operation. So all this, okay, with how remote sensing work, it is based on the interaction of the reflected energy with the surface. So amount of electromagnetic energy which interact with the vegetation, particularly if you see visible wavelength, that is ranging from 0.4 to 0.7 millimicron. So this wavelength is highly useful in the photosynthesis process because of presence of the chlorophyll pigment. This wavelength, which is ranging from 0.4 to 0.7 and cover red, green and blue wavelength, is absorbed and utilized in photosynthesis. That is why reflectance in satellite image in visible wavelength or red or green or blue band you will find very less compared to near infrared range, that is ranging between the 0.7 to 1.2 millimicron. So this is a particular wavelength range which is mainly scattered. If healthy crop is there, because of good cell wall, a cellular structure, there is a multiple scattering you will find at the cell wall interface. So healthy crop, healthy cell wall, healthy structure, it scatter more near infrared range. Then there are three bands, 1.4, 1.9 and almost 2.4. These are the three water absorption band. So because of presence of water in the leaves, it absorbs short wave infrared wavelength. So these are the three short wave infrared bands. So it is absorbed by the plant. If plant leaves has water, more water, if healthy crop is there, it has got more water. So this short wave infrared wavelength is absorbed. So what I want to say, that is why this band, short wave infrared wavelength, it is very much useful for generating land surface wetness index. And also, if you include along with near infrared, red and blue or green band, if you include short wave infrared band, then it can improve acreage estimation or crop discrimination. Particularly if you see crop like potato or crop like those crop which has got fleshy leaves, more water content in their leaves, you can, or mustard also. So you can, if you want to discriminate those kind of mustard or potato crop, if you include short wave infrared band along with the near infrared, blue and other band for classification, we will surely improve. So that we'll see later all those things. So how this NDVI, there is a one index which you can compute from the remote sensing data called normalized difference vegetation index. So it is nothing but NIR minus R, near infrared wavelength minus red wavelength or visible wavelength divided by near infrared wavelength plus visible wavelength. That is called normalized difference vegetation index. Now here you see, if healthy crop is there, how NDVI is there? NDVI, okay, here more reflectors you will find in case of near infrared range, but less reflectors in case of visible, because more absorbent because of chlorophyll concentration. So finally NDVI will be more than 0.7. But if there is a stress crop or stress vegetation, then what will happen? Near infrared reflectors will goes down and these visible reflectors will goes up. Finally, this NDVI become less, around you can say 0.1 to 0.2. That is a drought stress or water stress crop. So NDVI is a good measure of canopy photosynthesis, canopy vigor or canopy vegetation stress. Now coming to our crop type identification, because all of you must be knowing, you all having a knowledge about cereal crops, which are the cereal crops, which are the oilseed crops, which are the cash crop, which are the tuber crops, and there are certain pulse crop. These are the different crops which are practiced. Now at the same time, we also know there are C4 crops, there are C3 type of crops. Like C4 is a sugarcane, maize, sorghum, wheat, rice, and other crops are C3 kind of crops. At the same time, we know that there are row crops, there are drill crops like rice, wheat, which are the mainly drill crops. Row crops is cotton, sugarcane, which are grown in the wide rows. So they are row crops. So all these different kind of canopy geometry, means row placing, different kind of its time of sowing and harvesting, as well as different kind of canopy architecture, C3, C4, or you can say plant height or its canopy cover. All these are different for the different crops, as well as apart from this, chlorophyll concentration and also the plant water content inside the leaves of different crops are also different. So what I want to convey you that remote sensing, that having the ability to detect these differences because of variation in the amount of energy being reflected from the different wavelength from different crops. So there are different wavelength from visible to near, from red, blue, red, green, blue, peculiar kind of spectral curve across the electromagnetic spectrum. So here I have shown you one slide figure where this is a figure of the Haryana. Whole Haryana district, mainly if you go in Haryana in the mid of February or first week of March, what you will find? You will find mainly three crops: wheat crop, mustard, sugarcane. Sugarcane you will find nearby Panchkula, Karnal, and some Pithoragarh. Not Pithoragarh, Panchkula, this Yamuna Nagar, and this Karnal. Mustard you will find nearby Bhiwani or lower area which is joining to the Rajasthan. Wheat you will find in Sirsa or some almost whole area. Sirsa, Panipat, Hisar, all almost you will find more proportion of wheat in Haryana. Now this is the one image what advanced this image we acquired, and we have generated spectra in 4 band: green, red, near infrared, sweet. Now here you see wheat in first week of March. Wheat is in generally it is in the peak growth stage, so it has got good cell walls, good cell structure, so it reflect maximum in the near infrared wavelength. But same time, mustard crop was almost about to mature or about to harvest, so it has got less reflectors because it has got dried leaves. But then last is a very less reflectors you will find in the case of sugarcane in near infrared range, because by that time most of the sugarcane is either harvested in case of ratoon, and some which is left sporadic field which are left, they are all dried, only traces are there on the field, or some ratoon stem, ratoon portion, small portion which is left on the ground, it is visible. So reflect it, these all kind of ratoon crops or these all traces, they do not reflect in near infrared because they don't have any good cellular structure. That is why this difference is there. So here what I want to say, that if you have one image, one single date image in the last week of February or first week of March, Haryana like region or Haryana or Punjab like region, you can easily classify different crops types. So this already I told, varying canopy architecture, canopy cover, leaf cover, composition, and phenology all affect the basic characteristic which makes them to distinguishable using different satellite data. Means these are the canopy cover, leaf cover, phenology. Phenology means timing of occurrence of different growth stage within the life cycle of any crop. So in particular field, if you go particular village, you will find certain crops in flowering stage, certain crops you will find in the just vegetative stage. So different crop has got different kind of growth stage, and that makes you unable to distinguish one from another. You know, like what our visible eyes, we can distinguish different if you have knowledge, agronomic knowledge, and if you knows the phenology of the calendar of the particular district, then you can easily choose right kind of satellite data to distinguish different kind of crops. So what is crop identification? Crop identification or crop discrimination, that is more concerned with classifying all crop types from each other. That means if your objective is to discriminate, then you supposed to classify or discriminate each and every crop from other crops. So it will be really a challenging task, because you cannot do discrimination of crop type in a particular district or block with a single satellite data, because there are many crops, different kind of crops are in the different growth stage. So what I want to say, that here different crops with the equivalent growth stage, or sometimes same crop with the different growth stage, you will find in the one single date. Like wheat, if you go to certain places, you will find wheat. If you have 15 February, if you go to even Bhopal, what will happen? you will find, okay, certain crop is just in the tillering stage. Certain field you will find in the just spike came out, just spike emergence stage, or certain, okay, even you will find in the anthesis stage in the mid of February. That is what we have observed in Bhopal. So, because farmers are not sowing wheat crop at a time, there is a variation in the time of sowing window in the order of 1 month to 1.5 months. So, crop will reach to different stages at different time. So, these different growth stages of same crop in a one particular image create confusion to classify crops. Similarly, if different crops are there, 4 or 5 crops are there, all crops are, their growth is same, so they look like same in the canopy satellite image, but on the ground they are different because their leaf area index or their canopy cover is almost same, so they are giving similar kind of signature in the satellite image, but on the ground they are having a different kind of growth stage, different kind of time of sowing and harvesting. So we need to have, for discriminating crop types or crop separation, there should be a multi-date data set or multi-temporal data set has to be used for crop type discrimination, because one date you discriminate with mustard, another date you can discriminate other kind of crops. Then crop acreage is mainly concerned with the only few target crops. Suppose your objective is to estimate only crop acreage of the wheat crop in Bhopal or in Jabalpur, then your all methodology, concept, your acquisition, timing of acquisition of satellite data, kind of satellite data, all you have to acquire specific to the wheat crop. Like wheat crop generally reach to the peak growth stage, maximum growth stage during mid of February to the first week of March in Bhopal or Madhya Pradesh also. So if you acquire in this window these 3 kind of satellite data, you can easily discriminate. But same thing, okay, it cannot be possible with the same date. You cannot discriminate mustard crop. So that example I will show you later. So this is one crop acreage. Their approaches are there, boundary layer approaches. Like all of you, okay, who are scientists or assistant professor, you may not be engaged in the routine work of crop acreage estimation, like what Department of Agriculture does. State government agriculture department, they do this crop inventory, crop acreage estimation. So for that, they are doing for whole state, Madhya Pradesh or Gujarat or Maharashtra. So they cannot use this kind of boundary overlaying approach. Boundary overlaying approach is useful for the small area, small administrative unit like block, tehsil or district maximum. Because here whole area, you have to take complete enumeration based ground truth information. Then you have to classify whole area into a different kind of crops. So this kind of taluka or one district, that is good for the research purpose or study purpose. So classification of all pixel or part of it through systematic sampling, means complete enumeration technique is done to obtain area of desired crops. Now here one example that these 3 images there, satellite data. Kaveri Tehsil, okay, we have done classification of Kaveri Tehsil by one student in Maharashtra, Kolhapur district. So in Kolhapur district there are different kind of crops, sugarcane, paddy, this sunflower and groundnut. These are the 4 major crops. So with the ground truth operation, because we went to field, collected the location information with the GPS. Also we have collected information for farmer. We have noted down also the timing of sowing and harvesting, different stages, different photographs. All this after taking this ground truth information from the field, student or person, researcher can classify this satellite image by marking this ground to site in the satellite image, then applying some classification algorithm like maximum likelihood, supervised classification, or certain other decision classification, decision tree rule, or you can say image segmentation technique. You can generate different kind of crop classification or crop acreage. So this is a Kaveri Tehsil, different kind of crops, how it is distributed in the area. Now you see here, okay, there is a rock outcrop is there, but like this, okay, here this Maharashtra, some fruits like Nagpur and this, where orange is there, you can easily discriminate even with the satellite data single date, because it is you will find prominent signature of the orange in Nagpur district. So you can do with the single date also orange mapping, orange crop mapping. Same boundary overlaying approach. Now confusion may arise in your mind that sir is telling okay only one district we can use or less than district, then why whole Haryana? So here mainly Haryana is a homogeneous state. You won't find much heterogeneity with respect to the type of kind of crops. There are hardly 2 or 3 crops. So here we have tried to do with the coarse resolution satellite data advanced strips and tried to map mustard, wheat and sugarcane, other crops and other vegetation in the Haryana district. And we got okay 70 to 80% accuracy also with respect to the area estimation of the wheat crop. So this kind of approach, okay, with single data you can do where okay monocrop region is there. But if you have multi-crop region, then always prefer to make use of 4 or 5 data of satellite image so you can discriminate kind of crops. Hello? Yeah, somebody else. So here you see one example of our Sahranpur Tehsil nearby Dehradun. So here we have taken okay some this okay list 3 images there. We have generated spectra. So paddy with even if you are having good ground truth information and if you acquire satellite image, when there is a complete clear distinction between the two variety, like what we have found in the last week of October. Old variety or you can say non-basmati variety and basmati variety of paddy. Basmati variety like Sarbati, which is having a different kind of canopy, and old variety that is has different kind of canopy. So we could able to even discriminate that paddy coarse grain variety and paddy fine grain variety, coarse grain Sarbati, and also sugarcane. So with the this kind of different, because it is all depends on the how good you collect ground truth, what is the satellite image acquisition. If you get the correct satellite image, good ground truth, timely ground truth, you can do even better classification beyond crops, like what we have done for the variety also, variety level or for the paddy. So it's all depends if it's a good satellite image is available at right time, when okay both varieties discriminable, you can do okay that kind of things also. So here this is okay all possible with the suitability also. You can generate suitability with the soil and other slope and other information to generate what is the suitability of this paddy and the other crops. Now as I said, because here I want to give you a glimpses about, because there that what we have discussed, that is advanced switch data, list 3 data, which are the mainly optical data. So those optical data you can use like okay in Kharif, if clear and good image available in the end of October, it's okay, but it is not always possible. Sometimes cloudy is there, you won't get. So it is not better if cloudy is there, you will not do your operational crop monitoring. Because if your operational scheme is there, area acreage estimation, you have to provide bulletin and acreage to the government in an operational mode, a strategic mode. You have to be prepared with respect to the kind of data. If optical data is not available, then you have to switch over to the microwave data. So like microwave data, radar set data, reset data, all available. So here you see even radar set and today your Sentinel-2 Sentinel-2 is our Sentinel-1 is available with the microwave data. So radar set and reset, you can generate this kind of profile. We have generated profile different 7 time data, 7 time whole growing season. So we can capture total crop growth dynamics of the rice. So basmati, non-basmati, and basmati variety. 5 time image we have taken different stages, and then we try to classify them with the decision true rule classifier to obtain different stages as well as different kind of crops. Now here you see how we can able to do this. Okay. So here mainly you will see there is a difference in the crop phenology. After certain crops, particularly this one crop non-basmati which is getting mature earlier compared to the basmati. So basmati is harvesting later compared to the non-basmati. So that difference makes you unable to differentiate between two variety in case of microwave data. And already we have seen in the previous slide, basmati two variety of paddy you can discriminate based on the clear signal, because if there is a distinction is there, if you get the correct image optical data when in particular it is not always possible in all region you will get that kind of separate signature, but in our Saharanpur it is kind of variety they are growing, so both are looks different on the ground as well as in the satellite image, so you can easily classify with the optical data, but not possible optical data in every region, so you can do it with the microwave data. So that was all boundary overlaying approach. But suppose you want to do like those who are doing operationally whole Madhya Pradesh or whole Gujarat acreage estimation. So for acreage estimation of different crops, you cannot do acquire satellite image of each and every district and classify. For that, doing such kind of classification for whole state with the list 3 data, you require almost 500 manpower, too much of computer processing power, which is not possible. So for this kind of state level or national level crop forecast or crop mapping, we need to do sample segment approach, sample stratified sampling approach, where whole area can be divided into different stratum based on previous season crop proportion or historical satellite image or agroclimatic zone serve as a stratum. For each stratum, further you divide into sample segment of 5 by 5 kilometer size or 10 by 10 kilometer size. 5 by 5 kilometer sample segment means grid. 5 by 5 kilometer grid you overlay and select only the 10% of this sample segment from every stratum to acquire satellite image. That 10 by 10 kilometer or 5 by 5 kilometer sample segment, what you have selected, for that you acquire list 3 satellite image, do classification, then those classified area you can extrapolate based on the stratum proportion of the crop area, then finally arrive at the district level estimate. So here you see Punjab. What one example I am showing, that is a Punjab, that is whole divided into 4-5 agroclimatic zone, 1 to 5, from bottom to top. There is 4-5 agroclimatic zones are there. In a one zone, every zone there are districts. One dotted line is there. There is district boundary. Within district, there are squares are there. They are representing only 5 by 5 kilometer sample segment. So in one district, here I am finding 4 or 5 sample segments are there. So 4 or 5 by 5 kilometer area or 10 by 10 kilometer area, you acquire satellite image like that. In the below slide, the grid is overlaid. Out of that 5 by 5 kilometer grid, only selected grids are satellite image acquired. Then those satellite image, in the second image, you see that square boxes satellite image is classified into wheat 1, wheat 2, wheat 3, sugarcane, forest and other crops. So here you see why we have taken wheat 1, wheat 2, wheat 3. As I told earlier also, sometimes okay, there are different crops in equivalent growth stage with similar kind of canopy cover, or sometimes same crop in the different growth stage, create spectral confusion. So here, if crop is in tiller in same area, crop is in, you will find the satellite image, crop is in tillering stage or flag leaf stage, or you can say anthesis stage. So all three has got different kind of tone and textural variation in satellite image. So they are giving different kind of signature. But you know, being an agronomist or being a scientist working in that area, you know that this is only the wheat crop. But satellite image is giving three different signature. So you are initially marking while taking ground truth them as a wheat one crop, which is a tillering stage, wheat two is a flag leaf stage, wheat three is a anthesis stage. Then mark in the satellite image, then use in the classification also wheat one, wheat two, wheat three, classify. Then finally you aggregate in the last image you can see you aggregate wheat one, wheat two, wheat three as a wheat one. Means make okay one general class. So directly you cannot classify wheat because there are lot more variation in the same image also on the ground. So you to take care of that, you have to initially take more number of class, then later you aggregate into a single class of particular crop. So here how this work, first is a you are using sampling plan 5 by 5 kilometer sampling, then taking ground truth while going to the field with the previous season satellite imagery. We are finding wheat 1, W1, W2 and W3. That is a wheat 1, wheat 2, wheat 3 sample where ground truth you have mark on the satellite image. Then M is mustard, P is plantation, mango orchard, G means ground area, some groundnut or some barren area is the B means barren area. So these all ground truth. Nowadays, because this is earlier image, nowadays you are having hello. Now nowadays you are having a satellite image. Hello, anybody want to ask? Okay, okay. So there is a I'm not able to. Here, so there are okay different kind of crops are there. With barren area and all those things, this you identify nowadays. GPS is there, so GPS you can mark the exact location of that particular site, then bring to your remote sensing lab, open satellite image in your computer and mark this in the image software ground truth. After marking, preparing training set, these all training site, you apply classification algorithm and train them with this ground truth site. So that algorithm will classify all other remainder pixel into a different kind of information class. So based on this, okay, further, okay, after identifying training site, you see also feature space, how each and everything is separable or not. If separable is not separable, you have to make more distinction. If overlapping class is there, all those things, then you have to see whether they are separable or not. Then if not separable, then you have to again refine your training set selection and improve the distinction in the feature space. Then after you classify and generate crop acreage estimation. Now once you generate acreage estimation of different sample segment, multiply with the stratified stratum based proportion of the crop area in general crop area proportion, then you can finally get the district level acreage estimation after area weighted estimation of the different sample segment. So in our earlier project like crop acreage and production estimation, it was started with the Department of Agriculture very early phase, that 8 crops were targeted, only major growing district of major crops, wheat, rice, sorghum, mustard, groundnut, cotton. Nowadays we are handling jute, sugarcane, other orchard crops. Almost 24 crops are covered, all MSP crops, minimum support price, which are okay with the ragi or other crops are also included. So almost 25 crops. Technology development for crop acreage estimation is either in progress or implemented. So right now, at least 14 crops where district level crop acreage estimation is given for the major district by our institutionalized center, Mahalanobis National Crop Forecast Center, MNCFC, which is located in Delhi. So his director was Dr. Shibendu Ray. Okay, very sorry to say that he expired because of COVID in May month this year. But that center has given a or bulletin acreage estimation for different district and developed many program like first horticulture crop assessment, monitoring agriculture drought, crop insurance, many programs they are handling at the Mahalanobis National Crop Forecast Center in Delhi. So that is the center which is institutionalized by ISRO, Department of Space. So what we have seen, that is a district level support, but if you want to do whole nationwide, if you want to do whole India, what is the wheat crop mapping? So for that you cannot acquire at least 3 kind of satellite image. You require certain post resolution image like WIPs or advanced WIPs, and this image is available almost 5 days. At least acquire every monthly one satellite image. This is for wheat and mustard. It is there now. So though you see the profile in NDVI, now from this NDVI is generated from satellite image. Now you see this is a wheat. By end of mid of November it start sowing, and then okay it is growing, reach to the peak growth stage in mid of February, and then by first week of April get harvested. But mustard, I am hopeful that most of you must have seen the mustard on the ground, how it looks, how it grows. Like mustard, it is sown little bit earlier by end of October or first week of November. Then it reached to the peak growth stage, vegetative stage, in the end of the mid of December. But if you see this, okay, if you see it is reaching to the mid of November or first week of December, peak growth stage. That is means all leaves are in vegetative growth stage. Then after it is coming to the down deep when the NDVI is declining. Reach to the first dip is achieved. This is only because this mustard crop turns yellow, flowering stage in the mid of January. When it turns yellow, flower doesn't have chlorophyll, so absorption of the chlorophyll, FBH absorption is reduced. As a result, NDVI goes down. Then after once okay, these flowers turns into a pods. The pods are green. Again green because of green index increase because of more chlorophyll concentration added by the green pods. So again NDVI increase and reach another peak in the end of January or first week of February. Then after sanation start, crop get mature, it get harvested by end of February. So or mid of February. So it has got 2 peak in case of mustard, in case of temporal NDVI, but if it is a wheat, it has got 1 peak. So what I want to convey to you that if your interest is to discriminate mustard crops, then you shall acquire satellite image during the flowering stage, that is a mid of January or end of January. If your interest is to acreage estimation of the wheat crop, then you supposed to acquire satellite image in the mid of February or first week of February when wheat crop reach to the peak growth stage. Now this is what crop inventory using satellite data. There are different time resolution. Like okay, suppose your interest is national level. Then you acquire advanced risk data almost every monthly or fortnightly and apply decision rule classifier to estimate rice and wheat crop. Well, these are the two staple dominant crop. But if your interest is state level for crop mapping, then you shall acquire a little bit fine resolution or moderate resolution satellite image like advanced VIPs. So here for Andhra Pradesh, there you can map rice and other crops. If your interest is district level, then you acquire these three images. There you can estimate rice, cotton in the one district of, example is shown in the one district of Andhra Pradesh. If your interest is block level, then you acquire 6 meter, least 4 kind of satellite data, which has 4 band, 5.8 meter resolution. You can classify banana, maize, chili in different kind of crops. Further you go, if you want do better, okay, like village level mapping, cadastral level map, or planning purpose, you acquire even cartosat or least 3, least 4. Better than that, peak word image are available. Space imaging satellite is there, which has got resolution on order of 2 or 3 meter. So you can do even village level mapping. Every field you can map what kind of crops are grown, and those satellites are mainly QuickBird and Rapid Eye, and these are the satellites which are available in some other countries or international NASA, all those things. You can use those for the precision agriculture. So multiple utilities there. Same data can be used for many applications. Satellite remote sensing, one important advantage is there. Once you acquire satellite data, you can use this satellite data for mapping different crop types. That is one goal. It can be used also for yield estimation. It can be used for studying different growth stages. It can be also done for identifying drought assessment, agriculture drought assessment. You can use also for irrigation crop water requirement mapping. So it is not like that, okay, once you have acquired satellite data, it cannot be. It can be used for multiple applications. Finally, you require knowledge to interpret satellite data into a different conclusive application. So now we'll see little bit of a village level application, high resolution satellite data, least 4, least 3, IRS1 span and least 3 or least 4 satellite is there, merge data. We can use this also same data for village level mapping and generating field level maps. So here one we have done for the analysis for the hailstorm damage, like okay, pest damage, crop insurance, or identifying the crop loss at field level due to different weather calamities, whether it is a flood, hailstorm damage, flood damage, or other kind of pest attack is there. So you need to have a, for particular farmer, how much crop damage is there. So you need to have a very high resolution satellite image. You need to have a very advanced technique for classifying satellite data into a field level crop map. So here that is one advanced technique now used for the village level or farm level cadastral level mapping is the image segmentation technique. Because earlier that maximum likelihood classifier algorithm or supervised classification algorithm, they are mainly using spectral difference, spectral data, spectral characteristic. But image segmentation, that use also the shape, like a orchard has got particular kind of shape, different crops field has got different kind of shape. So it use along with the color, that means spectral data, it use also space and other kind of information to further improve the classification. So the whole image is categorized into this image object. These image object are further classified into different kind of crops. So you are seeing here different shapes are generated. They are nothing but image objects. So those image object in the one satellite image, that is a Narhara, one village is there in nearby Meerut. So this is a potato dominant growing areas in Meerut. So whole village there, okay, potato. And on that particular task we have taken is that assessment of the potato crop damage due to hailstorm. So we can assess this damage only if we have, okay, analyze how much potato crop was there and how much is damaged. Okay, how much area was there under crops and how much area is affected. So you require one image before hailstorm damage, you require another image after hailstorm damage. Then you have to make some change analysis. So here you see we have applied different algorithm: MXL, maximum likelihood, supervised classification algorithm, and image segmentation to classify potato crop. So you see, image augmentation technique always give you the best accuracy, more than 90% for the potato crop, but same is not with the supervised classification procedure, because it is finally using only the spectral data. By object-oriented image segmentation, it is a much better classified algorithm for the field level or farm level crop generation. So hailstorm, okay, you see one is a before image hailstorm, pre-hailstorm, and after hailstorm. You see in satellite image that red signature, red color. Okay, before hailstorm there was, okay, very good crop. Now after hailstorm, all is looking like barren. The whole crop, potato crop, is majority damaged. So you see also in form of NDY also. NDY has declined lot. All barren area, blue area is all barren area. In previous, before this, it was not like that. So we have classified into different kind of field and overlaid with the field boundary map. This is a field boundary cadastral level map from the Patwari. That field boundary is overlaid over the satellite image as well as the classified potato, slide, and different kind of affected, hailstorm affected parcel with the field boundary map. Similarly, okay, we are doing, okay, many things like this, okay, for the sugarcane milk catchment. There are so many sugar factories are there across India, whether it is Gujarat, Maharashtra, MP or UP. All sugar mill factory require how much sugar cane will come to their factory for crushing. So they need very critical information: how much sugar cane is produced, if sugar cane area is there, and how much sugar cane, millable sugar cane will come to their factory for crushing. Based on that, they will decide the crushing capacity. So this kind of vital information is useful for the sugarcane mill owner and to decide catchment crushing capacity. They require prior information about the sugarcane area, cultivated area, and possible yield production forecast. So we have done also for the sugarcane field level crop area mapping, its different growth in the Saharanpur 1 Nanota Kisan mill. So with the high resolution satellite data list for every field is mapped with the, and then with the reasonable accuracy. You see this, okay, image segmentation and MXL classified for the sugarcane Nanota Kisan mill catchment area sugarcane crop. Similarly, another, because this is a one Department of Food and Public Distribution under Ministry of Consumer Affairs by Government of India, has given a one mandate to develop prototype sugarcane crop mapping with the remote sensing data for the government. So government mill, all sugarcane mill, they can take this initiative. They can develop their remote sensing cell in the every sugarcane mill, so they can operationally monitor sugarcane production, how much available, and accordingly they will give the sugarcane payment to the farmer. So this is another in the Bagpat Tehsil. With the multi-date data, we could able to generate sugarcane crop level map with the both decision tree and image segmentation algorithm. So you see here. So all field boundaries are there. So ratoon sugarcane as well as planted sugarcane, both are mapped with the two type of classification algorithm in the Bagpat Tehsil. Then okay, this ratoon and both kind of sugarcane is mapped in the Bagpat area. So for you, those who are okay, research scientists or assistant professor, all these what I am showing, that is all published literature, published research, which is available in some international journal for your reading. So those who are interested critically can mail to me for further. I'll send you all these reprint, print or publication article to you. Also, apart from this, okay, field crop inventory, it is nowadays has got immense potential to generate or map agroforestry system also. Agroforestry, silviculture, horticulture, agro-horticulture, then also crop haze farming with the high resolution data, with the multi UAV and other kind of data set also. Now it is very much possible to derive agroforestry system. So we could able to do certain things with the LIS4 and PAN high resolution satellite data. You see all green area. That is all field boundary with the poplar. Haze plantation is there on poplar on the side of the field, and certain inside there is a certain is a mango orchard, certain is a totally sugarcane wheat field, certain is without boundary of trees, certain field is with boundaries of trees. So all crop haze with the boundary we could able to detect with the high resolution satellite image. One is a world view that is available at a resolution of 2 meter. So we have got better accuracy with world view image, where you can see every field boundary also. And we could able to classify poplar tree boundary or eucalyptus tree boundary around the field. In policy planner level or your larger level like Indo-Gangetic plan, if you have data all these okay available on the multi-date, it is possible to generate cropping system: rice, wheat, sugarcane base, cotton base, rice, potato, maize, wheat, different kind of cropping system using the pre-season satellite data or every monthly satellite data. You can classify based on the decision to real classifier, and you can generate the cropping system of different areas. Further, you can generate also how much cropping index is there, what is the diversity index is there, land utilization index based on the cropping pattern. This statistic also you can generate for, and this is very much useful with respect to the crop diversification. Now government has got one specific project on crop diversification, national mission on crop diversification. Under that, we need to study cropping pattern, how diverse is land utilization index, cropping index, all you have to generate, and finally it will help to make decision making related to the improvement in the diversity of the crop types in a particular region. Because earlier we were used to grow only rice, wheat, or in certain area only rice, wheat, rice, wheat. Now rice, wheat system itself is not sustainable anymore. So now we need to diversify our agriculture. So we need to study what is the diversification possible with different kind of fruit or vegetable crops we will include in our farming system. It will be more remunerative to the farmers, as well as it will be good for the sustainability of the agriculture. So like cropping system for Punjab. And finally, what I have said, told you that there is a one center, MNCFC, Mahalanobis National Crop Forecast Center. So this is a center which is mandated with the crop production forecasting and agriculture monitoring. It is institutionalized by Indian Space Research Organization. Now it is working in the Department of Agriculture. So they are giving all this state level assessment of crop map and crop forecast and crop production forecast as well. Various software is also developed, like mobile application for ground truth collection, crop insurance, also pest and disease survey, and Fasal Shop for the classification. All new technological development is going on with respect to improvement in the agriculture crop mapping. But lastly, I want to convey to you that there are limitations also, because India is a big country. We don't have like, okay, field size is as high as European America America and Europe, they are having a field size in the order of 100 hectares. We have the average field size is 0.5 hectare, even less than that. So with such a small size of field, it is very difficult to resolve with the available satellite partial resolution in the space orbit. Second, large diversity of crops shown in the area. In India, we have, okay, as I said, in Maharashtra, Gujarat, Madhya Pradesh, 1 hectare field, a farmer can grow certain part for the fodder, lucerne, certain part for the wheat crop, certain portion for the vegetables, certain portion for the cash crop, and even certain portion he will grow for certain other kind of crops. So 4 or 5 crops will be there always in a 1 hectare of field. So if such a kind of large diversity is there, it is very difficult to, because all these crops are not sown at the same time. They are sown at different time. They are different kind of canopy characteristic. So it is really posing a challenge against the surveyor or the researcher to map all different kind of crops. So third, large field to field diversity in sowing culture and crop management practice. Sowing culture means sowing window. All farmers are not growing their crops at same time. Depending upon their economic situation, depending upon the favorable climatic condition, the land preparation, they are sowing their crop or available crop input, seeds or crop inputs. So always you will find 1 month to 1.5 month variation in the time of sowing window of any crop in any village. So this, and also management practice is also different. Those who are landlord or well-to-do farmers, they have tractor, they have every facilities, irrigation facilities. They grow first. They prepare their land first. Once, okay, they are having some spare. If their every work is complete, then they will rent to this marginal farmer, tractor or all those things. Irrigation facility available, 1 or 2 irrigation to marginal farmer if it is in surplus with them. So those marginal farmers, they cultivate at the last, those landlord who cultivate first. So there is a long variation in the sowing time of sowing of window. Then practice of intercropping and mixed cropping. Intercropping means growing of 2 or more crops in the row arrangement. Like, okay, we will find bajra groundnut. There's many kind of, okay, intercroppings are there. Mixed cropping, different season, like, okay, in Uttar Pradesh, wheat and mustard, they grow together. So you cannot, okay, wheat and mustard is grown together. How you can acquire satellite image to classify them? Because you won't get any satellite image to detect weeds or mist crop. Then high cloud coverage during kharif crop. Okay, now problem is solved to certain extent with the availability of microwave satellite data. But even though microwave satellite data, that is development of the sensor which can enables you to monitor high biomass crop like sorghum, bajra, or maize, is a little bit challenging. It is still in the research stage. We have not succeeded to fully utilize those microwave data for monitoring this kind of crop. Only rice is, as of now, well proven technology available only for rice. So it is still challenging for to estimate acreage of crops in the kharif season with the microwave data. There are different factors which affect crop identification: radiometric and partial resolution, number of bands, time of acquisition, that's scenic satellite image acquisition, atmospheric condition. Like, okay, atmospheric condition, if it is a hazy atmosphere is there, like what is in the Dehradun or which means Meerut, Muzaffarnagar and Ghaziabad, you will find, okay, January and February almost fog. Visibility is almost up to 11, it is not there. Most of the satellite acquire image before 11. So you will not find correct satellite image during January, February when your wheat crop is grown. So it is hindered by the atmospheric condition. Crop proportion and environmental factor all affect the possibility of crop identification. So finally, challenge wise, if you want to cultivate for farm related decision, we need to have multispectral data with more number of bands with the extent real time large scale area application. We need satellite data with 50 to 100 meter daily, 50 to 30 meter every 5 day, 5 to 10 meter resolution every 10 day, and also possible constellation 3 to 4, like okay resource set 2A. If we have okay 3 to 4 resource set kind of these 3 satellite data operating at a time, so we can reduce that okay repeat cycle of 20 days it is available. Instead of that, we can get at least weekly these 3 images if you have 3-4 satellite at a time that can meet. Then some GIS at high resolutions daily half hourly satellite image that can also helps to derive information for farm decision making like precision agriculture. So this is thank you all. Dr. Sharma, Nema.
Thank you, sir, for this wonderful lecture. It's quite informative, sir.
Yeah. Okay.
All the participants, if you have any questions,
Yeah. Actually, that is. If any have any query, question, you are free to interact. Even if you are not okay right now, you people are busy, you can always welcome to put a mail to me. I'll answer each and every mail.
Thank you, sir.
Hello, participant. If any query is there, you can put on in front of me. Dr. Saurabh?
Yes, sir.
Yeah. So these all participant is heterogeneous group or they are assistant professor or what?
Sir, basically this training is being conducted for all the professors, assistant professors, basically assistant professor scientist for JNKVV.
So they are having the agronomy background or different background?
They are from the different discipline of agriculture, sir.
Not agronomy or agrometeorology or plant physiology.
Including agronomy, agrometeorology, and all the disciplines, sir, all the agriculture discipline, all the participants, basically the assistant professors, scientists.
Because why I'm asking, because those who are agrometeorologists, plant physiologists, agronomists, they are having a basic knowledge about the every crop, what are grown, when it is grown, and what are the characteristics. So that is why they can better choose the satellite data. Time of acquisition of satellite data is very much critical while taking up the inventory of crops. Okay, anybody, any question is there? Okay, then thank you very much for patiently listening me. Thank you.
Thank you, sir. Yes. Thank you, sir.
Thank you, sir.
Thank you.
Thank you very much. We'll meet tomorrow.
Thank you, sir.
Okay, thank you.
All the participants, we are closing the session for now. So tomorrow we will meet at 10:30 a.m. Thank you very much.